Hi, welcome. This lecture on Laplace transform, part 6. This is a continuation of the previous part, that is part 5. In the previous part, we had solved a differential equation, this one, d square y by dt square plus dy by dt equal to t square plus 2t, using Laplace transform. We have taken Laplace transform of this equation, we substituted the initial values, and we have arrived at this simplification. If you have not seen that video, please see that. I'm giving the link. I have given the link below for that previous lecture where this equation, differential equation, was solved by taking Laplace transform and obtaining this equation ys. And after this, yt was found, that is the inverse, Laplace inverse of this function was found by partial fraction method. Now this is another method, alternate method for finding the inverse. So we will not use partial fraction method, but we will use a direct method. Here I have, this is ys which you got from the previous lecture by taking Laplace transform of this equation. Okay, now I split this term. So this is the term I split. There are 4 terms in this. I written these 4 terms separately. 4 by 4s power 4 by s power 4 is this first, and next 2s cube by the denominator, simplified 2 by s into s plus 1. Next 2s by this is this, and the last term 2 by s power 4 into s plus 1. Okay, so now if you take the first term, this one, 4 by s plus 1, the inverse of 1 by s plus 1, you know, is simple, e power minus t. So for the remaining terms, we will use this formula. You know that integral, Laplace of integral f of t dt equal to f of s by s. Laplace of this integral is f of s by s, then the inverse of f of s by s is f of t dt, integral of f of t into dt. So we will use this formula for the remaining things. Now if you take this 1 by s plus 1 as f of s, then f of t is e power minus t, right? The next term, this is 1 by, this term is, can be considered as this f of s divided by s, right? So 1 by s into s plus 1 is this term divided by s is this. So if the inverse of this is e power minus t, then the inverse of this f of s by s is integral of this f of t dt, right? So we understand this. If this is f of s, then this is f of t, the inverse. Then this one is f of s by s. Then the inverse of this is integral of this f of t from 0 to t. So if you do this integration, you get this integral of e power minus et is minus e power minus t. You substitute the limits, you get minus e power minus t plus 1. Now the next successive, again if you consider this as f of s, if you consider this as f of s, this is going to be f of s by s. S has become a square here. This by s is this. So if the inverse of this is, the inverse of f of s here is this, then the inverse of f of s by s is integral of this from 0 to t. Okay. So the integral is written here, is easily self-explanatory. Integral of these two terms, you get this, and when you substitute the limits, the upper limit is e power minus t plus t, the lower limit, this becomes minus 1, lower limit of t is 0. Next is again divided by s, this f of s by s. So inverse of this f of s is this, then inverse of this f of s by s is going to be the integral of this from 0 to t. Okay, f of s by s is integral of this from 0 to t. So when you integrate this and substitute the limits, you're going to get this. You can see integral of e power minus t is minus e power minus t, integral of t square by 2, minus 1 is minus t. When you substitute the limits, upper limit they are same, the lower limit only this term exists, minus of minus 1 is plus 1. Now similarly 1 by s power 4 into s plus 1, this is this function by s. So inverse of this will be integral of this from 0 to t. So if you do that integration, if you substitute this and integrate, you are going to get this minus this is plus, integral is plus e power minus t, then t cube by 6, minus t is minus t square by 2, integral of 1 is plus t. If you substitute the limits, upper limits are same, lower limit only this minus 1. Now let me substitute all these things in this equation. So s plus 1 term, that is this, then s into s plus 1 this, then square is not there, s cube is there, s power 4 is there. So I'll substitute this all in this equation. So for s plus 1 by s plus 1 is this, 1 by s into s plus 1 is this, s cube into s plus 1 third term, and for this one. Now let us simplify this. First let us take e power term. We have this (4) into e power minus t minus 2 into e power minus t, again minus 2 into e power minus t. So these three terms cancel out. So you're left with only this e power minus t. Next, if you take t cube terms, you have only one t cube term here. So that will be 2 into t cube by 6, that will be t cube by 3. Then t square term, so this and plus t square by 2 and minus t square by 2 multiplied by 2 cancel out. Similarly minus 2t and plus 2t also cancel out. So left with this term only minus 2 or plus 2. You have minus 2 here, then you have plus 2 here, cancel out, plus 2 and minus 2 cancel out, and you have this 2 left, so plus 2. So this is the final answer which we got by direct use of this formula. So previous part, we have done the inversion, Laplace inverse by partial fraction, and in this case we had used this formula. So sometimes partial fraction method will be easy. Sometimes when you have some 5-6 constants, finding out partial fraction and evaluating the constants may be a lengthy procedure. So in that case, we may be looking for alternate method, which if it is simpler. So in this case, we have an advantage. This s plus 1 factor is occurring in all the terms, and also all the terms differ only by factor of s. Yes, here s cube and s power 4. So it has become convenient for us to use this formula and arrive at the answer without resorting to partial fraction. So you should be aware of different methods, that's all. So this is the answer. For this is the solution of the differential equation which we got by, in the previous lecture we got by doing the inverse by partial fraction, and here by using the simple formula. Okay, I hope it is understood. We'll see more examples in the coming lectures. See you.